Let's graph some log functions. We are going to look at the graphs of some basic logs, that is, logs that are not transformed. And the best way to do that, in my opinion, is to get some ordered pairs. And I think the easiest way to do this is to take whatever the base is and find some y values for powers of that base. The typical choices that I make are 2 to the negative 1, 2 to the 0, and 2 to the 1. Plugging in negative 1, 0, and 1 on the given base will give us sort of the bend of the curve. And the rest of the curve is pretty easy to draw once you sort of know where the corner of it is. So when we take log base 2 of 2 to the negative 1, those 2's will undo each other and we'll be left with just the exponent of negative 1. If we take log base 2 of 2 to the 0, we get 0, and log base 2 of 2 to the 1 is 1. Now another way to think of 2 to the negative 1 is as 1/2. So that tells us that the corresponding ordered pair is 1/2 comma negative 1. Similarly, 2 to the 0 is 1, so the corresponding ordered pair is 1 comma 0. 2 to the 1 is just 2, so that ordered pair is 2 comma 1. So this gives us the bend of the graph, the corner of the graph, and it is going to look something like this. It will go on forever towards infinity, but it will be growing fairly slowly. It's going to approach the y-axis as x gets closer and closer to 0, but it will never touch the y-axis. The y-axis will act as an asymptote. Let's take a look at another one. Let's suppose we have y equals log base 5 of x. Again, my suggestion, look for 3 ordered pairs and find those 3 ordered pairs by taking the base and raising it to the negative 1, 0, and 1 power. The corresponding y values will be negative 1, 0, 1. And if we want our ordered pairs, we simply come over here and evaluate. 5 to the negative 1 is a fifth, 5 to the 0 is 1, 5 to the 1 is 5. So that tells us that our first ordered pair is 1/5 comma negative 1. And then our next ordered pair is going to be 1 comma 0. And then our third ordered pair is 5 comma 1. So what we see is that the base is going to correspond to the x value with a corresponding y value of 1. So if we had log base 10, we'd have to go all the way out to 10 before we have a function that has a height of 1. So that's going to be our graph. And let's do one more. Let's do one with a fractional base just to mix it up. So let's suppose we have log base 1/3 of x. So same idea, we are going to need to plug in x values that are powers of that base. I suggest, once again, 1/3 to the negative 1, 1/3 to the 0, and 1/3 to the 1. Our y values will be negative 1, 0, and 1. And if we evaluate these to get our ordered pairs, 1/3 to the negative 1 is 3. 1/3 to the 0 is 1. 1/3 to the 1, of course, is just 1/3. So let's take a look at what happens here. So our first ordered pair is 3 comma negative 1. And then 1 comma 0, we will see that 1 comma 0 is on every logarithmic function's graph if it's a basic logarithm, if it's not transformed. And then 1/3 comma 1. So what we see here is that we have logarithmic decay. So the function will look sort of like that. The y-axis is still going to act as an asymptote. But when we have a fractional base, we are going to have a logarithmic graph that is decreasing. It's going to go down as the x's get larger. Kaboom!